Today your lesson is on lines in the coordinate plane. We're going to look first at slope. So the slope of your line is the change in how your line is moving. Normally you look at your lines from left to right. So just like you're reading a book, from left to right, you look at these lines. Your slope is going to be found by taking the change in y over the change in x. So you're going to do y2 minus y1 over x2 minus x1. That is your formula to find your slope. So just like it says on here, your slope is found by taking y2 minus y1 over x2 minus x1. So let's say if it gives you two ordered pairs, you choose one of those ordered pairs to be x1 and y1. You choose the other ordered pair to be x2 and y2. Plug in your values and simplify. If we look at example 1, it tells us to find the slope of the line passing through each pair of points. For example A, we're given -2, 0, and 3, 1. So again, for all of these, we're going to use our formula for slope, which is just y2 minus y1 over x2 minus x1. So for A, again, -2, 0, 3, 1. I'm going to label my -2 as x1 and my 0 as y1. My x3, or my 3 is going to be x2. My 1 is going to be y2. So again, plugging this into our formula for slope is going to give us 1 minus 0 over 3 minus -2. Double negatives turn into a positive, so that gives me 1 over 3 plus 2, which is 5. So it's just 1/5. For example B, we have the point -1, 2, and 2, 2. So I'm going to label my -1, 2 as x1 and y1. That 2, 2 we're going to label as x2 and y2. So again, we're going to use that formula for slope. So y2 minus y1 over x2 minus x1. We're going to have m is equal to 2 minus 2 over 2 minus -1. Once again, we're working with double negatives, so they turn into positives. So that's just 2 minus 2, which is 0, over 2 plus 1, which is 3. 0 over anything is what? 0. So your slope for this one is 0. For example C, we have the ordered pairs 0, 4, and 1, -1. So to find our slope, again, we're going to do y2 minus y1 over x2 minus x1. I'm going to have that 0, 4 as x1 and y1. The 1, -1 is going to be x2 and y2. So that's going to give us a slope, or m, of -1 minus 4 over 1 minus 0. Your -1 minus 4, they have the same sign, so combine the two numbers, keep the sign in front of it. That's going to give you a -5 over 1 minus 0 is 1. Anything over 1 is itself, so your slope for this one is just -5. If we look at 2 pages after what we were just looking at, you have different types of slopes here. So if you look at the first one all the way to the left, you're reading this line from left to right. So you'll see from left to right that line goes up, so that means that it has a positive slope. For the second one, you have a negative slope because from left to right that line is going down. For the one that's second to the right, you have a slope of 0. So that's going to be a horizontal line. That's going to be any line that is y is equal to a number. This, when you have a slope of 0, means that it's 0 over a number. for something like the one on the far right, you have no slope. So a vertical line is going to have no slope, and that's going to be x is equal to a number for the equation of that line. For this one, your slope is going to be a number over 0. So whenever 0 is in the denominator, it's undefined. So slope is just undefined. You can also tell me that there is no slope for one like that. Okay, so from left to right, if the line goes up, it's a positive slope. Left to right, the line goes down, it's a negative slope. Horizontal line, your slope is 0. It's also the equation y is equal to a number. The slope that is undefined or no slope would be a vertical line, so up and down, and that's x is equal to a number for your equation of the line. And then your slope would be, like I said, undefined or something over 0. The next part that we're going to look at is point slope form. Point slope form of your lines or your functions is in the form of y minus y1 is equal to m times x minus x1. So you're going to be given the slope and an ordered pair, and you're going to be told to write the equation of the line in point slope form. When that is the case, replace the y1, the m, and the x1 from this formula. That's all you have to do. If we look at example 2, it tells you to find an equation of the line that passes through the point 1, negative 2, and has a slope of 3. So if we're putting this in point slope form, our formula is y minus y1 is equal to m times x minus x1. It tells us that the ordered pair that we're working with is 1, negative 2. So from this, our x1 is going to be the 1. Your y1 is going to be the negative 2. It also tells you that you have a slope, or m, of 3. So we're just plugging these three numbers into our equation. That's the y minus y1 is equal to m times x minus x1. So y is not going to change. Minus y1 we said is negative 2. Is equal to m, we said is 3, times x, doesn't change, minus x1, which is 1. From here, the only thing that you are going to simplify are the double negatives. So double negatives turn into positives, so that becomes y plus 2 is equal to 3 times x minus 1. And you'll leave it in point slope form. So you'll leave it just like this. For our next example, it tells us to find the equation of the line that passes through the point negative 4, 9 and has a slope of negative 2/3. So once again, the equation in point slope form is y minus y1 is equal to m times x minus x1. The ordered pair that's given to us is negative 4, 9. So our x1 is going to be negative 4, our y1 is going to be 9. It also tells us that we have a slope of negative 2/3. So plugging these three values into our equation, we're going to have y minus y1, which we said is 9, is equal to m, which is negative 2/3, times x minus x1, which is negative 4. Once again, you have double negatives with that negative 4, so that turns into x plus 4. So it's just y minus 9 is equal to negative 2/3 times x plus 4. This is going to be going over slope-intercept form and then your parallel and perpendicular lines. So slope-intercept form is that y equals mx plus b. It's just that equation that's on the bottom of that page there. So you could literally get a point and your slope, plug it into point slope form, and then turn it into slope-intercept form by solving for y. So we're going to look at doing that today as well. So again, keep in mind that y equals mx plus b, which is your slope-intercept form, and then also keep in mind your point slope form that we did yesterday, which is the y minus y1 is equal to m times x minus x1. So for example 4, it tells you to determine the slope and the y-intercept of each linear equation, then describe its graph. We're just going over the the y-intercept and the slope from these. So with both of these, we want to solve it for y. For a, we're given x plus y is equal to 2. We're going to move that x over by subtracting it from both sides. So that gives us y is equal to negative x plus 2. If we are working with slope-intercept form, which is y equals mx plus b, where your m is your slope and your b is the y value from the y-intercept, we are going to use that y equals negative x plus 2 to find your slope and your y-intercept. So if we're comparing this to our formula, the m is the negative that's in front of the x, which just means negative 1. Then your b is the 2. Again, that 2 is the y value from your y-intercept. So b is equal to 2 is not your y-intercept. Your y-intercept is the ordered pair 0, 2. So the important parts from here is that your slope is negative 1 and that your y-intercept is 0, 2. For example, B, you're given y is equal to 2. Now, this does not have an x involved in it. So if you were to write it with the x involved in it, it would just be y is equal to 0 times x plus 2. The 0 is what turns the x into 0, because 0 times anything is 0, and gets rid of it. So if you were to simplify this, you would be with the y is equal to 2. So from here, our slope, or the value that's in front of x, would be 0, and our b is 2. So the slope is 0. That's not going to change any. The b is 2, which means your y-intercept is the ordered pair 0, 2. For your next example, it tells you to find the equation of the line in slope-intercept form of the line that goes to the points negative 3, 1 and 5, 2. This does not give you your slope, nor does it give you your y-intercept. So if that's the case, you have to first find your slope, then use your slope and one of the original points that it gives you to put it into point-slope form. After putting it into point-slope form, you're going to solve that equation for y and put it into slope-intercept form. So the first thing we need to do is find the slope from these 2 points. Remember, the slope is y2 minus y1 over x2 minus x1. Your x1 and your y1 we're going to use as the negative 3 and the 1. The x2 and the y2 we'll use with the 5 and the 2. So plugging these values in, that's going to give us m is equal to 2 minus 1 over 5 minus negative 3. The 2 minus 1 is 1. 5 minus negative 3 becomes 5 plus 3, and that's just 1 over 8. So your slope is 1 over 8. We're going to use that and one of the original points to put it into point-slope form. The point-slope form is y minus y1 is equal to m times x minus x1. From the beginning, we said that y1 is 1. We found that m is 1/8. And we said in the beginning that x1 is negative 3. So if we plug these values in, we're going to have y minus 1 is equal to 1/8 times x minus negative 3. Double negatives turn into a positive, and you're going to work with y minus 1 is equal to 1/8 times x plus 3. From here, you have to solve this for y. Distribute the 1/8 into the set of parentheses. Multiply by each of those terms. You're going to have y minus 1 is equal to 1/8 x plus 3 over 8. From here, you're going to move that 1 over by adding it to both sides and getting the y by itself. In order to add that 1 with the 3/8, what does it have to turn into? 8 over 8. So that way it has the same denominators. So we are going to do 3/8 plus 8 over 8, which simplifies to give us y is equal to 1/8 x plus 11 over 8. Keep it as an improper fraction in simplest form, and that is your answer. For the next thing that we're going to look at, we are going to find the equations of the lines that are parallel and perpendicular to given ones. So parallel lines will have the same slope. So make a note on that they will have the same slope if they are parallel. Think about the fact that there are two L's within the word parallel, and those two L's are the same. Your slope will be the same. If we look at the next example, it tells us to find the slope-intercept form of the equation of the line that passes through the point 2, -1 and is parallel to the line 2x minus 3y is equal to 5. In order to find the slope from the very beginning, we have to find the slope from the given equation. So that 2x minus 3y is equal to 5, we're going to solve that for y and put it into slope-intercept form so we can identify our slope. I'm going to move the 2 over, or the 2x over, by subtracting it from both sides. So that's going to give us negative 3y is equal to negative 2x plus 5. From here, we divide each side by the negative 3. Remember, when we do this, it's each term that gets divided by that negative 3. So that's going to leave us with y is equal to positive 2/3 x minus 5/3. If we are looking at this in slope-intercept form, what is our m, or our slope, from this? 2 over 3. Because our slope is 2 over 3, and we're working with a parallel line, which is going to have the same slope, our equation that we're going to find is going to include the slope that is 2 over 3. We're also going to use the point that's given to us for the new line, which is 2, -1. The 2 is going to be your x1, the -1 is going to be your y1, and you're going to plug those values into y minus y1 is equal to m times x minus x1. It tells us that we want our equation in slope-intercept form, so we then have to turn that into y equals mx plus b. So use that y minus y1 is equal to m times x minus x1 and plug in those values. So this is going to give us y minus -1 is equal to 2/3 times x minus 2. The double negatives turn into positives, so that's going to be y plus 1. You're also going to distribute that 2/3 into the set of parentheses with the x minus 2 to give us 2/3 x minus 4 over 3. From here, move the 1 over. Subtract it from both sides. So that's going to give us y is equal to 2/3 x minus 4/3 minus the equivalent of 1 with a denominator of 3 is 3 over 3. With these two fractions that are like terms, you have the same sign. So keep the sign, add the numerators, keep it over the denominator. That's going to give you y is equal to 2/3 x minus 7/3. That is your equation of a line in slope-intercept form that is parallel to the line 2x minus 3y is equal to 5. For the next part, we are going to look at finding the equation of a line that's perpendicular to a given line. So with perpendicular lines, you're going to change the sign and flip the fraction of the slope. So make note of that. For perpendicular lines, you are taking the opposite sign in the reciprocal, or you're changing the sign of your original slope and then flipping it. Remember, if you are changing or taking the reciprocal of a whole number, it becomes something or 1 over whatever that whole number is. For this example, it tells you to find the slope-intercept form of the equation of the line that passes through the point -9, -5, and is perpendicular to the line 3x minus 4y is equal to 9. So first thing we're going to do is to put that 3x minus 4y is equal to 9 in slope-intercept form and identify our slope. We're going to move the 3x over, so we're going to subtract it from both sides. This is going to give us negative 4y is equal to negative 3x plus 9. From here, we're going to divide each side by the negative 4. Remember, when we're doing this, it's each term that gets divided by the negative 4. So that's y is equal to positive 3/4 x minus 9/4. The slope from this is what? 3/4. If we are finding the line that is perpendicular, that means we're flipping the fraction and changing the sign on it. So the slope that we're going to use for the perpendicular line is going to be what? Negative 4/3. The ordered pair that we use for the new line that's perpendicular is -9, -5. So your m is the negative 4/3, your x1 is the -9, your y1 is the -5. You're going to plug that into y minus y1 is equal to m times x minus x1. From there, you'll turn that into slope-intercept form. So if we plug our values into that green equation, that point slope form, we're going to have y minus -5 is equal to negative 4/3 times x minus -9. Double negatives on both sides of that equal sign become positives. So that's y plus 5 is equal to negative 4/3 times x plus 9. Next step is to turn this into slope-intercept form, so we're going to solve it for y. Distribute the negative 4/3 first into the x plus 9. So multiply both of those terms by the negative 4/3. That's going to give you y plus 5 is equal to negative 4/3 x minus 4 times 9 is 36, divided by 3 is negative 12. You could also take the 3, turn it into a 1, make the 9 a 3, and just do 3 times negative 4. From here, we're going to move the 5 over, so that way y is by itself. So subtract the 5 from both sides, and that leaves you with y is equal to negative 4/3 x minus 17. So the line that of the equation of the line in slope-intercept form that is perpendicular to the 3x minus 4y is equal to 9 is y is equal to negative 4/3 x minus 17.